Yo-ho! What's up, everybody? Happy Taco Tuesday. Is that copyrighted yet by LeBron James of the Los Angeles Lakers? They're taking everything from us. They're taking our Twitch music away. They're taking Taco and Tuesday away from us. Really gotta watch what I play on here. But yeah, I'm back. I'm resuming where I started from last time. If you're just joining us, we're gonna learn how to program today. Or at least you will. I already kind of know how. I could be much, much better. And maybe I'll get better by showing you how to get better. But first, let us start this programming lesson with a San Miguel Pale Pilsner. One day they'll pay me. Oh, let's begin. So when we last were programming, let me make sure I put this shit on the gram. Yes, I did. All right. It's the only social media I really care about these days. Okay. So, last time we did this, we learned, what did we learn? We learned types. We learned how to print text. We learned how to cast to different types of variables. And now, I believe I promised you guys that you'd learn about Booleans. So, a Boolean is just another type. Like an integer, like a float, like a string. But a bool stores can only have two kinds of values. It's either true or false. So you can store conditions in these booleans. Man, these iMessages keep coming up. It's all good. So let's revisit that guessing game we were trying to play, or we coded up the last time we did this, where we have a number, in this case 3. We have a prompt, aka just a message that we pop up and we send to input. So when input comes up, it asks you, your dumbass has one chance to guess this number. And once you enter in a number by keyboard, it'll store that number in here. It'll cast that to an integer. Because remember, you can't be comparing different types. I mean, you can, but why? In this case, you want to compare an integer of 3 with an integer of whatever you guessed. So we do results. If the result equals the number that we were trying to guess, then you won. If not, or else, you suck / lost. Now what we can do, excuse me, San Miguel burps. So we're gonna store the results in here. We're gonna call it guessed correctly. How about that adverb? Results equals number. So we're gonna say we're going to store the result of result equals number, which will be either true or false, depending on what you put, depending on if it equals this number. We're gonna store it in guessed correctly. And then, you could straight up do an if guess. My old man brain is going crazy. Guessed with a T. If guessed correctly, hey, you won. Otherwise, hey, you suck. Let's see how that works. I'm not even in the same directory as this. This is terrible. My sister said yas. I wonder if she's watching this right now. Hey, Jan. Hope you're doing okay. All the way on the other side of the world. Almost. So, Python lesson.py. Oh, she's probably not even... nah, she's probably responding to, what's his name? I forgot. Anyway. So, your dumbass has one chance to guess this number. So, I'm gonna guess 4. Hey, you suck! /lost. AKA, I didn't guess correctly. Guess 3. Interesting concept. Even I'm stumped on that. Why? Oh, my silly ass. It's because I once again compared with the string version of the input and not the number. Ha! I won this time. Okay. So, that's a Boolean. Just another integer. I'm sorry, just another variable type. You got your ints, your integers as declared here. You got your strings as declared here. And then you got your Booleans as declared here. And you can do that for any kinds of types. Maybe we'll even declare our own types today. Okay. I'm sure I'll edit over this and add a real explosion sound effect. Or maybe add some cool sirens or something. Like what DJs use. So we went over Booleans. What are we going to talk about now? We did conditions. We're going to do loops. We're going to do loops. So, man, where do I even begin? There are for loops, and there are while loops. So, maybe I should just teach you guys how to while loop first. Let's comment all this out, because we don't need it anymore. Damn it. No. No! Okay. Loops. So, as I said, while loops and for loops. We'll work on the while loops. While loops will keep executing whatever code is inside it until it will loop based on the condition you passed it. And if that condition is ever if it ever evaluates as false, it'll stop. So remember, it's a good thing I taught you guys Booleans just now. So how about let's say we want to count down from 10. How about, wait, did I teach you guys how to do math? Yeah, I did. God, I hope so. Yeah, I taught you guys how to do algebra and store things in variables. Okay. Yeah. We should be alright. So, if number equals 10, we're going to count down from 10. And how do you do that? Well, first you got to realize, so you start from 10, and then when do you stop? When you get to 0. So, while number is greater, so you want to tell the while loop, hey, we want to keep, these kids just keep setting fireworks off. In June, it's not even July, whatever. Just have to deal with that. So we're gonna have to give it a condition, right? That seems pretty good, right? While this number, this variable that we stored the number 10 in, while this number is greater than 0, what are we going to do? We're going to print its current value and we're going to... I can't say I've never said decrement before. Is it decrement? As in the opposite of increment? I don't say decrement that much, so I'm gonna hope that's how to pronounce it. I'll look it up in a dictionary eventually. But let's just say I'm gonna print the number, and then I'm going to subtract 1 from it, because that's how you count down, right? 10 minus 1 ends up being 9. Oh, I shouldn't even be teaching you those kinds of operators yet. How about we just say, there we go. That's nice and friendly for now. So, Happy New Year. Okay. So, let's go review what this code does. We're going to have a number. So we're going to count down from 10, right? We're going to go print some numbers. So we're going to start at 10, right? Number equals 10, because that's where we're going to start. And this while loop, we're going to get into these loops. And this loop will continue as long as this variable is greater than 0. And we're going to print... What are we going to do? While that number is greater than 0, we're going to print that number. And then for the next iteration of the loop, we're going to subtract 1 from it, so it becomes 9, right? And then, so this is going to evaluate to 9, and we're going to store that into number. So this, by the time it checks that number is greater than 0 again, it will be number minus 1. And then when that's all said and done, it should say Happy New Year. Let's see if it does what I think it's going to do. Are you hacking E Honda so he can throw fireball and... What's up, iSize Matters? No, I don't... Man, how would I even... I think, well, first off, I would have to have a pretty good handle of the Unreal Engine. I can't say I... Man. I'm not really good at reverse engineering. Man, that would take me a while. I imagine I would have to get... Yeah, look at this guy. Look how confused he is. He's got a microphone in his face. This motherfucker. Let me get him. Let me get him in the frame. There we go. Pluto's been confused. You ever have a San Miguel before? Ugh. How about a Red Horse? You have any of those beers before? Anyway. Yeah, let's go. Let's run this. Aha! These fucking fireworks here. Oh man, it's like, I want to say it's like the official beer of the Philippines. I could be making that up. I probably am. It might be Red Horse. I don't know. Anyway, well, they're made by the same company, so who really knows? What is going on here? Okay, so man, can you tell that I'm streaming on? Hey, Hogarden's good. I hope I'm pronouncing that right. Hogarden. I know it sounds offensive, but it's pretty good beer. Pretty good, got to say. I usually have that at my friend's place. I usually bring a 6-pack over to his place, and then his parents probably think I'm a delinquent or something. But anyway, we did exactly what I thought we were gonna do. We started from 10, we count it down to 1, because 1's still greater than 0. Once this becomes false, it just totally bails out of this loop and doesn't execute that stuff anymore. Oh man, you're playing with my feelings, man. Oh, I wish I do have pork rinds at home, but I actually already had dinner. It's Taco Tuesday over here. We had some Baja. Is it Baja Cali? I told my wife to get us 8 tacos. I mean 8 tacos for me, but I only ate 6. Shameful. I thought I had a bigger appetite than that, but nothing wrong with that. I'll eat the rest of them tomorrow. Second dinner? Nah, man. I'm trying to be healthy. I ran 3 miles today. I feel pretty good. I've been spending most of this what's it called? Plague working out more, because usually when I have to drive to work, that's like on average an hour there, an hour back, and if I feel like it, I'll try to get some workout in, but nope, this time I'm being healthy. Anyway, yeah, man, we did exactly what we said we were going to do in this loop. We started at 10, we printed what number was at the moment, we reduced it by 1, and we checked. If it's still greater than 0, then we print it. And once we got to 0, 0 of course is not greater than 0. That condition returns false, and so we bail and just say Happy New Year. The power of computation. Or what happens if we do 100? Can it still do that same stuff? Yes, it can. Look how crazy that was. That's why I've always liked computer programming. Just you're able to make computers which do things way faster than a human could ever do. Way quicker. But there's some things humans can do better, like describe pictures and things like that. But we're getting there. We're on the way. We're working it out. So that was a while loop, and now we're gonna work on a for loop. So a for loop that operates on every element in an iteration. Every element in an iterable structure. What is an iterable structure? Oh, damn it. I should have taught you guys how to do lists. Let me teach you guys how to list right now. So lists is just another type. So we got, what did we talk about? We got our integers. We got our floats. We got our strings. And now what do we have? We got lists. What's a cool name for a list? List underscore number pi name. Oh man, yeah, have a good lunch. What you having for lunch? So, what is a list? It's exactly what you think it is. A list. You can add things to it. You can subtract elements from it. You can even put multiple lists together. There's all sorts of crazy things you can do with a list. You can. There's just so many ways to do it. What if you want a list full of even numbers and things like that? It's crazy out here. So let's see what happens when you print this list, just so you have an idea of what a list can do. So let's start with printing out all this these other variables that we declared. God. Yep. It's exactly what I thought would be. Now, what happens when we print a list? Get out my way. Yep, that's exactly what it is. So, a list, we have a list containing those three things we just declared. A number, a float, and a name. Now, Python's great because some other programming languages, like C++ or whatever, or can it have a list with... Anyway, what's special about this list is that you can add all sorts of objects to this list. Doesn't matter what type it is. You can add all sorts of types to it. I think there's a name for that. I just forgot what it's called. But yeah, you can put anything in this list. Back when I was programming in C++, you could only have a list of certain types. Like you can only have like a list with integers in it or floats in it. I don't know how far they've gotten. C++ has evolved so far. I don't even know what they're doing anymore. But that is a list. And what if? Perfect way to deal with the for loop. Actually, let's demonstrate more about what other things we can do with a list. Shoot, we can, if you want to add stuff to the list, there's a couple ways you can do this. You can append some random number. Yep. We can insert, and you don't even have to put it directly at the end. You can insert it. I believe this puts it... Yeah, that's where I thought. I believe this will put 23 in the first position. Yep. Okay. And then you can even add multiple elements to the list by extending it with another list. Ah, there we go. And another way you can add stuff to a list. I'm going to say the word concatenate and hope that's the way to say it. So what if if you do list, you can combine them together like that. Now we got double the fun. And those are all the cool things you can do with a list. Remove things. Actually, how do we do that? Is it pop? Oh, okay, so there's remove where you can you give the element that you want to remove. Like, I'm trying to remove that 23. There we go. But you gotta run it again if you want to kill that other 23. Or, if you wanted to remove... There we go, pop. If you want to remove... Let's say we want to remove the last part of it. Oh, wow. I gotta teach you guys everything. I gotta teach you guys how to slice... I gotta teach you guys how to slice lists. Let's say I wanted to kill the, So our list looks like this right now, right? If I wanted to pop off this second thing, I would put in 1. Oh, did I mention that when you... Oh, I gotta deal with indexes. Oh, gosh. Okay, so when you have something that's iterable like a list, you address elements in the list by their position, by their numerical position. First, second, third, or whatever. But the thing is... Why is that line still... Anyway. Give me a second. Nah, forget it. BRB. Go. Okay, where was I? Where was I, folks? Oh, slicing. Okay. So when you're trying to address elements in a list, you do it by index, and it actually you don't. If you're trying to address the first thing, you would think that you would access it by putting a 1 in there. No. For some reason, and in most programming languages, it all starts at 0. So let me just reduce the list to looking like those 3 elements again. Okay. So if I wanted to print the first element, I would use the indexing operators. Oops, sorry, put a 0 in there. Behold, we just said the first element of this list. If I want the second element, I do 1. So, good rule of thumb is whatever element you want to access in a list, it's whatever element n minus 1. That's how you get to it. And then there's a little thing called slicing. This is pretty helpful. Oh, I'm sorry. Before I get to that, for some reason when you do Python's crazy, man. There's when you enter negative indices, this doesn't have you can't really do this in all languages, but Python's cool. Let's say you wanted to access the last element of an array or a list. You do -1. Crazy, isn't it? So the second element from the last, there we go. That's why if I wanted to pop off the name, simply pop off index -1. There we go. And then there's slicing. Damn, do I really want to talk about slicing right now? Sure. So let's say I wanted all the elements except the first. The first element. So I'm gonna say list is now going to address the original list starting at the second element and so on. I feel like I should add more things in here to accentuate how well this stuff is working. Or how about just remove the list without the first two elements? Yep, that's how it goes. Or how about what if I want the first three elements? It's crazy out here. I never would have conceived of list slicing like this, but there's a lot of great features of Python that I might not even get to, but this is just one thing. I'm trying to drop some kinds of gems on you, and this is one of them. So, yeah, that's how to do things with lists. A list is an iterable object because we can pass it into the for loop, which I wanted to talk to you guys about. Let's say we want to print every element inside the list. What is this stuff? There, we did it. We did exactly what we came here to. Our list had some number. Pi is definitely more than 3.14, but that is outside the scope of this lesson. And then we got name, Santa, Maria. So let's print that out. And we do. Every single thing in here gets printed out on its own line, and then the loop stops when it has gone through every single object in this iterable object. There's another kind of list. I think it's pronounced tuple. Tuple's like a list, but it's constant. Meaning, once you make it, you can't really do anything to it. You can create new ones out of it, but it's mainly for declaring constants. So that's one way to do it. You can cast a list to a tuple and a tuple to a list, and much the same way it traverses it. The thing about tuples is, like I said, you can't do anything to it. Pretty sure, yeah, see, pop doesn't even exist for it in the auto-completion for its function. So, that's how those tuples work. Alright, so we got, man, what have we gone through? I taught you guys about while loops. Taught you guys about for loops. Oh, here's what I should teach you about flow control. So there's you can actually break out of a list. Break out of a loop with this neat little function called, well, not really a function, but I forgot the noun for it. Feature? Sure, call it a feature. Basically, if Python is processing a loop and it comes across break, ends the loop immediately. So let's say we have our list here, and for some strange reason, we wanted to bail right after we get to my name, my first name, Andrew. So we'll print it still, but we're gonna break out after seeing Andrew. We don't care about seeing Santa, and we don't care about seeing Maria. So that's where your loops are in there, and that's, wow, that light is, I should have charged that light. Really should have charged that light. Next time I'm going to charge that light after every streaming session. Anyway, so let's say we wanted to break out after we print Andrew. So this is where our conditions come in. It's a condition with a loop, in a loop. So when do we want to break out? If the thingy is Andrew. Let me comment that out. So without the condition, we are, let's print the list. Why does that thing still stay? It's so annoying. Okay. We have a list. It has a 10, a pi, my first name, the first part of my last name, and the second part of my last name. And then currently we're just traversing it and printing every element of that list. Now, well, if we put this condition in, we're going to loop through it. We're going to print the element. And if that thingy equals Andrew, aka my first name, we're breaking out of here. We don't care about the rest of the elements. We are breaking out of this loop. Oops. Can't forget the colons when it comes to conditions and loop declarations. There we go. 10, 3.14, Andrew. We didn't care about Santa Maria. We just bailed. Easy as that. But what if I'm just coming up with loop scenarios that we can code just so I can show you guys. So what if we didn't care about seeing the name Andrew print out? There's another loop control. It's called continue, which skips over, which goes to the next element. Oh, sorry. It in a for loops case, it moves to the next element. In a while loop, basically it just if you're in a loop and Python sees continue, it's going to totally disregard any of the remaining code in this loop and just go back to the condition. Or, in this case, go to the next element in the iteration. So, without this condition, we're going to see all the elements in this list. But with this condition put in, it's going to traverse each element of this list. And if the element that it comes across just happens to be my first name, it's going to skip right over. Otherwise, it's going to print it. There we go. 10 pi Santa Maria. You are now a master of for loops. Man, what else can I teach you guys? I got like 15 minutes left. What do you guys want to know? You guys want to learn about classes? Are you guys ready for classes? Or should I teach you guys about recursion first? I think I'll teach you guys about classes. Shoot, I might I might need a refresher. So so we were making types, right? I mean, so we've been working with types. We got, integers, strings, floats, bools. How about, we even got lists. But, those are just primitive file types. What we need is we need to be able to create our own types. How about, what is a good class to make and abstract from? I'd say shape. So today's the day we make a shape. Shape. And man, did you guys take geometry? I hope to God that you guys have taken some kind of geometry. Cause I'm gonna be talking about calculating areas. I'm gonna talk about perimeters. All sorts. Yeah, let's just work with areas for now. So we got a class. Shape. Man, I have to explain everything. This teaching programming stuff is harder than I thought. I thought I could just be like, oh, here's a loop, here's a for loop, here's a while loop, you're done. No, there's way more shit that I totally just remembered just now, and this is terrible. This is terrible. So any great shape, any great class has to be built, and usually the first function that's called when a shape is built is a function called init, surrounded by 2 underscores, both in the front and both in the back or end, both on the left and right. And then okay, good. I taught you guys how to use functions. So first you say, hey Python, I want to make a class. It's called shape. And then while we're in the class, we say, hey Python, I want to make the constructor for the shape. I want to make the first function shape runs when it's constructed. Real simple. Real nothing too crazy. Damn, how do you make abstract? Man, I'm gonna have to teach myself before I teach you guys how to make classes. Nah, I think it's smart. It's smart enough to do that. In C++, you have to like straight up say, "Oh, this is an abstract class," and "Oh, this is a virtual function." But I do believe Python knows how to take care of that stuff. So let's create a shape. So just like when we created a variable, we're going to. It's called shape. I mean S. We're gonna have a variable. It's called S, and it's gonna be a shape. And we got to put these parentheses here to say we're constructing a shape. If we didn't have these here, we'd be saying S is a reference to shape, and that's not what we're trying to do. We're trying to make a shape. Let's see what happens. Yep, it is absolutely right. That is a shape. Alright, now for the crazy part. How about rectangle? So, man, not to teach you guys about polymorphism and, oh god, and inheriting things. So, one of the great paradigms of programming, which are still used to this very day, is called object-oriented programming. Back in the day, I'm not gonna pretend that I'm from the back in the day. I was born in '88, but object-oriented programming is a great way to organize your code because it's pretty much how you would describe objects in the real world. And that's how they store data about people in a database. Like, okay, you are a person. What does a person have? A name, an age, the eye color, things like that. And you can store all these things in a class. So, but first you need an abstraction, like a person, or sorry, an even more abstract, a bigger abstraction to be like animal or something. So, I should have used that. I should have done that. That way I can just say, oh, height, and anyway. Yeah, fuck it. What am I using shapes for? We're gonna abstract animals. Everybody knows animals. Oops. Animal constructed. Just so you know what's up. So, what's an example of an animal? A cow. So we're gonna say so basically we just told Python, hey, we're gonna make a class. It's called cow. It's basically an animal. But first, let's work on this. Oops. Hold on a sec, folks. Oh, why my shadow? Whatever. Noise. We're gonna have a function that's gonna be different depending on what kind of animal is constructed. So. Generic animal noise. Yeah, I should totally figure out how to, I guess, I don't think Python has something like that, do they? They have a... No, there's a... Oh, now I have to teach you guys, decorators. I'll teach you the guys that next time. Man, Python's complicated. Okay, so... Animals. They typically have noises. Forget this constructor for now. I'll need a better lesson plan for that. But, say we got a cow. What sound do cows make? I've been raised on moo. So basically we said... we basically said, hey Python, let's create an animal. Let's create an animal class. Let's create a class called animal, and it's gonna have a function. These animals are gonna have a function called noise, and when you run this noise function, which takes no parameters other than, well, that self just means that noise is a member function that's a part of the animal class. So back to our original declaration of animal, or instantiation of animal, we're gonna do noise. We're gonna say, hey Python, let's create an animal, store it in A, and let's make it run its noise function. There we go. Generic animal noise. Now, then we say, hey Python, let's create a cow, which is basically animal. Oh, I should teach you guys. Let me teach you guys a little bit about inheritance. But first I have to teach you about pass. There's so many things I gotta teach you guys. So, pass. It never ends. The lesson never ends. So, we got pass, which kind of takes the place of... You're basically telling Python, I am a line of code, but disregard anything. Just skip right over me. Because if I didn't have this here, Python would be like, "Hey man, where's the rest of where's the rest of your cow declaration?" Yeah, see. But if I say pass, I'm basically saying, "Hey Python, just create this cow that's basically an animal, and that's about it." I have a bad feeling I have some comments here unclosed. Let me just kill all this code here. Really? Where's the rest of this part? Interesting. Oh! Wow, I missed it. One more parenthesis. I mean, sorry, one more apostrophe. Sure. So if I didn't have pass there, it'd be like... Okay, maybe it wouldn't be like... That's strange. I learned something today, too. Anyway. So when I create an animal, I try to bust out a noise. And it says general animal noise. But if I create a cow... Notice how I made a cow and I made it do a noise and it still said generic animal noise. That is because I inherited the noise function from animal because this cow is basically an animal. But I don't want it to be a generic animal noise. I want it to moo. That's what cows do. Moo. So let's also make a noise in here. And damn it, what is the word for it? Override? Sure. Whatever I don't figure out now, I will teach you guys in the next lesson. So, we said, "Hey Python, let's make a cow," which is basically an animal. Yes, I inherited noise, but I want to use my own noise. I want to say moo because I'm a cow. I don't need no generic animal noise. Moo, as it should, because it's a cow and not just some animal. And that is inheritance, and I don't want to have to say function overriding because I feel like that's the wrong term. I know that's inheriting. You're inheriting the noise, and then what? Overriding? God, it probably is. But dang, what else can I teach you guys in like 5 minutes? Man, what else can I? There's so much more. There's so much. I think I've... Oh. You guys want to learn, what is it? Recursive functions? You guys know what factorials are? Damn, this is crazy. Let me teach you guys a little... If you guys don't remember what factorials are, let's say you want to do 3 factorial. 3 factorial is 3 times 2 times 1. So basically, it's whatever that number is, multiplied by all the preceding integers before it. Now, there's actually 2 ways to do a factorial. You could do it as a loop, right? How would we do that as a loop? So we got like, what is it? n. So n, and while n, oh, just like last time, while n is greater than 1, so we got, what? We say, well, first we start with 1. And we say, well, handy thing you want to do is, always check your, arguments. Always check the parameters passed into your functions, otherwise you get some weird behavior. So factorial typically works for things greater than 1. Okay. So in this function, factorial, we'll call it factorial loop, because we're doing a factorial, but we're going to do it the loop way. So we're going to take an integer. So I got to teach you guys about hinting. Sure. See, this is actually a kind of new feature in Python ever since, I want to say, 3.6. I could be wrong. Could be 3.7. But, it's helpful. You're basically telling whoever's reading your code that, hey, this argument, this parameter for this function is supposed to be an integer, and it's supposed to return an integer. I don't believe it forces that, but it's like a, hey, it's a pretty good idea if this returns an integer. Anyway, so we got this factorial function. First, it checks that it's a number that is great. First, it checks that you actually put in a positive number greater than not less. If it's less than 1, which you shouldn't be doing, it'll just say, why'd you do that? And then we got product is what we're going to be returning. And using the parameter we just passed in, and while it's greater than 1, we are going to multiply that number with product, stored it in product. Oops, ooh, that would have been bad. And then subtract n by 1, and that will be the next number that is multiplied with product and stored in product, effectively multiplying with all the preceding integers until it's equal to 1. And returning that product. Let's see. So 3 times 2 times 1, basically 6. Oops. So that's how to do it as a loop. And that very well works. But there's another way to do it, and that is with recursion. I don't know if they taught this in schools. They did it in my computer science classes, but given a condition, sorry, that's Oops. Sorry. They texted me. A recursive function is basically a function that calls itself and stops calling itself depending on a condition. Kind of like how loops work, but you basically use the function itself to continue doing the work. So we got so how can we do a factorial using the function itself? Well, just like this. But first we need to lay down some conditions, or else this fact, if it keeps calling itself, it's gonna keep continuing forever. So we need an ending condition. So if n equals 1, how do you do this? It's been so long. Oh, just return. There we go. I believe. Yes, I believe. Oops, I'm sorry. If n equals 1, premature optimization. Okay. All right. Okay. That should yeah. I'll take that. So, we got this, believe it or not, these kids and their fireworks pretty much does the same thing as factorial loop, but in a totally different manner. While this needs a loop to calculate factorial, this calls upon itself to calculate the factorial. And you'll see that it does that exactly how you think it does. So there's so first, just check that you're not passing in any silly parameters. So here's the exit conditional, or the thing that pretty much stops the whole factorial. If n equals 1, just return 1. That's pretty much how to end this the calling of factorial recur. Just return 1. If n otherwise, what it's expecting is the number you originally passed in, and you multiply that by a call to n minus 1. Pretty crazy. And I wish I had a whiteboard or something to draw. I'm sure a nice diagram would help explain how much this works, but you'll see. Let's run it. And I hope I wrote the right code. Aha! Perfect. Let's see what happens. So we did factorial recur 3. So let's go through the code. Factorial recur. Pass in a 3. It's not less than 1, so we're not going to say why would you do that. It's not 1, so we're not going to return 1. But, so, probably don't even need to put that else there. But I think it's good for, yeah, you don't need that else there, see? It works just fine, but I wonder if that helps for clarity. Anyway, 3 is not 1, so we're going to return 3 times factorial recur 3 minus 1, aka 2. This is going to be 3 times factorial 2. So let's go back into this function. Let's see what factorial 2 does. Once again, it's not less than 1. It's not 1. So we're going to return 2 times factorial 2 minus 1, aka 1. So what happens when you call that? Factorial recur 1. It finally equals 1. So let's return 1. So if you pop right back up, the last time factorial recur was called, that ends up being a value 1, which gets multiplied with 2. And the last time factorial recur was called, 2 times 1, so we get 2. And for the last time that was called, factorial recur was called, so 2 times 1, 2, and that was 3. 3 times 2, 6, thus completing the recursion. And man, I'm tired. My voice feels very raspy and my throat hurts. Hope it's not coronavirus. I hope it's just because I've been talking so much for the past hour and 11 minutes. I usually don't do this, but man, I need some water or something. That was pretty fun, guys. that was wild. We must have covered way more stuff than last time. We went over booleans, we went over loops, we went over list slicing, we went over for loops, while loops, recursion, classes. Man, this might be the most educational stuff I've done all day. Tune in next week. Probably. Who knows? I don't know. I can't predict the future, but I have a pretty good chance I'll probably do this again. We'll probably have to have some really good lesson plans next time. Maybe, I don't know, develop some games, develop some real utilities. Who the fudge knows? But, yeah, man. If you like any of this, follow. You know where to find me. Subscribe. You know where to find me. OCD Savant on Twitch. And at your local Street Fighter tournaments. And on PlayStation Network. And if I ever own an Xbox, maybe I'll call myself OCD Savant on that too. But if you like what you saw, you can find me on Instagram, Andrew Santa Maria. Or you can find me on Twitter, Andrew Santa Maria, without the E between the R and the W. Or you can go to andrewsantamaria.com for all your Andrew Santa Maria needs. I have been, you guessed it, Andrew Santa Maria. So, take care, everybody. Wash your hands. Black Lives Matter. And don't you forget that. My job here is done. I am out of here. Good night, everybody. Take care. Enjoy yourself.